After completing this lecture, you can list different data modalities that AI models are designed to work with. Another index in recognizing data comes from the data modalities. Data modalities refer to the different forms of data that can be collected, processed, and analyzed. These modalities represent the various ways information can be captured and expressed. Examples of data modalities include tabular data, that is, a structured data organized in rows and columns often found in spreadsheets. Graph data, that models topological relationships in the data structure. Visual data, including images and videos. Audio, that is, sound recordings, including speech, music, and environmental sounds. Text, which is data in written or printed form, such as documents, articles, social media posts, and emails. There are other ways to tag different data types. So you may hear, for example, time series data, that are data points collected or recorded at specific time intervals, such as stock prices, weather data. Sensor data, that are commonly referred to the information collected from various sensors, including temperature, humidity, motion, and pressure sensors. Or geospatial data, related to the geographic location of objects, including maps, GPS data, and satellite imagery. Concerning different data modalities, different AI models or modalities are developed to handle these varieties of data. For tabular data, classical machine learning models, such as linear classifiers or nearest neighbor clustering algorithms, are mainstream. For text, varieties of NLP models are used for processing high-dimensional text data. For audio, which includes temporal piece of information, AI models are developed to model sequence processing that are often similar to text processing models, including RNNs and transformers. For visual data, including photoimagery, illustrations, video recordings, and graphics, computer vision models are used to handle extremely high-dimensional data, such as convolutional neural networks and vision transformers. For topological data, graph neural networks are the state of the art to process the node and the edge information on the graph structure. All the aforementioned input data modalities are processed and used to make prediction as the output of the models. For example, in computer vision tasks, the images are taken as input and the AI model are used to tag objects in the images, such as persons or clouds in our example image. In NLP models, the language as text is given, and the model can predict the feeling associated with the sentence in sentiment analysis task in our example. Therefore, the outcome of both models could be text, even if that for the computer vision model, the media is image, and for NLP is the language. Regarding the output of the AI model, so-called prediction, we can categorize the AI as generative or discriminative based on what it produces. Loosely speaking, if the prediction or the model output is on par with the nature of the input data, that is, the statistical distribution of the data, is called generative. Recently, generative AI has been very successful in integrating AI into our daily life, from large language models, including GPT, to image generation models with breathtaking results. A discriminative machine learning or AI model, in contrast, is used in classification and regression tasks that focuses on modeling the decision boundary between different classes. In our example, you see the semantic segmentation that discriminates between different objects in the image.